Okay, folks, good morning. Yeah, not the 170 students I thought would be here, but that's okay, first day. So welcome to Computer Science 2211B. My name is Jeff Shantz. I'll be your instructor for this course. Is it better with the light at the front on or off? Better on or off? Off? Okay. All right. So today we'll just briefly go over some administrative stuff. I'll just give you a quick bio of me. We'll talk about what we're going to focus on in this course, talk about what resources are available to you to be successful in this course, talk about how you're going to be evaluated, some of the course policies, and how you get help in this course. So just quickly about me, I am the Associate Director of Science Technology Services here at Western. We are the IT support team for the Faculty of Science. So we do everything from general technical support. We offer a private cloud on campus that we maintain, that we can spin up servers on demand for researchers and grad students doing research. We do custom software development, that sort of thing. So I've been in this game for well, over 20 years and over 15 years of experience in various system administration and development roles. Have a lot of experience with Linux, which is one of the big topics of this course. So yeah, hopefully you should be in good hands. I also teach every now and then in the department. I've taught everything from first to third year. I went through this program just like you folks are doing, so I'm familiar with all the courses you're taking. And yeah, long-suffering Toronto Maple Leafs fan and a very untalented drummer. Bought myself a drum kit for Christmas. Not going to be going on tour anytime soon. So what are we doing in this course? This course is 50% Unix or Linux, 50% C programming. So Unix and Linux. Unix was developed back in the 60s. It's a family of operating systems. You may have heard of some of these terms like Solaris, HPUX, AIX, BSD. Very big with major corporations and universities at the time. And then Unix essentially inspired numerous Unix-like operating systems. So you may have heard of things like NetBSD or FreeBSD. Certainly Linux is one of the most popular Unix-like operating systems. macOS, for those of you who have Macs, I see a whole bunch of you. You may not know you're using a Unix system. It's based on BSD Unix. Android. Android is Linux as well. It's a Unix-like system. They took the Linux kernel and modified it to run efficiently on mobile devices. And so that is also a Unix-like operating system. So in this course, we're going to be focusing on Linux specifically. It's probably the most popular of the Unix-like operating systems. It's free, at least server side. It's free and open source, so you can go out, you can download it, you can use it. You don't have to pay anything for it. As we'll talk about in a few minutes, it effectively powers the internet. So you may have heard of Linux distributions like Ubuntu, Fedora, Debian, and so on. There's a ton of different Linux distributions out there for a variety of different purposes. So whatever kind of suits your fancy, you can go out, you can download it, and yeah, freely use it. So we'll be focusing on Linux in this course, but the basic concepts that you learn about any Unix-like language apply to, or any Unix-like operating system, I should say, apply to any of them. So you know, if you learn the commands on Linux, you'll know what to do at the terminal on your Mac, for example. Or if you happen to go work for a company that uses Unix, you'll know those commands as well. Occasionally, there's some syntactic differences, like maybe, you know, there's the ls command, and maybe on one operating system, it takes a few different arguments than on another. But for the most part, all of the basic commands are the same. So you learn one, you pretty much know them all. Now, we'll also be talking about the C programming language. This was developed in the 70s at Bell Labs. And essentially, at the time, they were building Unix in assembly language. So the problem with that, of course, I don't know if any of you have taken CS2208 yet, but it's slow, right? It takes a long time to develop assembly language. It's fairly cryptic, and it's not very portable. When you develop a program in assembly language, you're developing it for a specific processor. So you can't take that assembly code and then go to some completely different processor and expect to run that. So they wanted a higher level language so that they could build their programs a little bit more efficiently and so that these programs would be portable. So they developed the C language. It became a success, and they started to then say, okay, well, we've written Unix in assembly language. Let's just rewrite the entire kernel in C as well. So C will be a little bit different than what you've experienced so far. First year, you folks are doing Python. Are you still doing Java? Yes? Okay. So far, you've only seen object-oriented languages, unless you've looked at this stuff on your own. C is a little bit different in that it's not object-oriented. It is a procedural language, so you don't have objects available to you. Nevertheless, you can do some very powerful stuff with C, and we'll see later in the course how even if we don't have objects, we're able to create data structures and work effectively. Yeah, we'll talk about the benefits of C in a minute, but just to point out that it has also inspired many C-like languages. C has been a very influential language. A ton of languages, C++, C#, JavaScript, PHP, those are all, they can be considered to be C-like languages in the sense that they were inspired at least somehow by C. So for example, C#, Java, JavaScript, PHP, those are all languages that have a C kind of look to them. They all use braces for their blocks. They all have semicolons at the end of their lines, that sort of idea. So it's been a very influential language. So here is my case for why you should care about this course and why you should care about learning Linux. First of all, it powers the internet. It's used on like the vast majority of public internet servers out there. Estimates put it at over 80%. So all the big players, Amazon, Google, Facebook, X, whatever, they're not running Windows servers, and I can tell you they're not running Mac servers, they're all running Linux. It powers mobile. As I said, Android. Android is essentially Linux. They took the Linux kernel, they customized it for their purposes, and voila, now we have Android running on like over 70% of mobile devices in the world, if you're counting cell phones and tablets and wherever else it runs. So it's very much a big player in the mobile space. It's free and open source, so the barrier to entry is very low. As I said, you can just go out and download, Ubuntu or Debian or whatever you want, play around with it. You could start a company with it and really have to pay no money unless you wanted to pay a company for some Linux support. The source code, it's open source, so you can inspect the source code, you can modify it, you can customize it to your needs, and again, that's exactly what they did with Android. It's considered to be a very secure operating system. It's got we're going to see about Linux permissions later in the course. It's got a very strong permission system, receives regular security updates, and it allows you to sort of really pare it down and run a very minimal installation with only the services that you need. And we say that reduces its attack surface. So the fewer services that you're running on a system, the fewer opportunities an attacker has to attack you. So it's a reduced attack surface. And of course, the fact that it's open source allows for people to scrutinize the code and take a look at it. And this happens all the time. Security researchers, are scrutinizing the code. They find a vulnerability and they report it. And then somebody patches it, and voila, now Linux is all that much more secure. It's also high performance. Linux is the kind of operating system where you can take an old PC from 10 years ago, you can throw it on there, and it'll run comfortably for you. You're not going to be doing any supercomputing with it, but it will run for you. Whereas if you do that with Windows, it tends to run very sluggishly. But at the same time, Linux powers all of the world's top supercomputers. So anytime you're doing any kind of high performance computing, you're probably using Linux. Finally, it's an essential job skill in this day and age, especially if you're looking to get into any kind of jobs like system administration, cybersecurity, cloud development, really any kind of job in IT, even if you're just going to be a software developer. Even if you tell yourself, well, I'm just going to develop games on Windows for the rest of my life. More likely than not, you're eventually going to have to touch Linux servers. Sure, you might be developing Windows games, but maybe they need to talk to some sort of server in the cloud, and that's running Linux, and you've got to develop some components for that, or at least deploy software to a Linux system. So having that knowledge and having those lines on your resume, that's a good thing for you. Now, just my final point here is, you will see these days the euphemism, oh, we're looking for full stack developers. Okay, so that's the employer's way of saying, we don't want to spend a lot of money on hiring all kinds of staff, so we want you to basically know it all. So it used to be that, you know, the developers would develop the software, they'd pass it on to the testers would then pass it on to the sysadmins who would deploy the software on the internet servers or wherever. Nowadays, they want you to be full stack developers. You need to be able to do it all. Develop that software, test it, and then deploy it to the server. So that's my case for why you should care about Linux. Now, why should we care about C? So first of all, if you want to do any kind of development, any kind of systems programming. So we're talking operating system development, developing compilers, developing device drivers, any kind of systems that interact directly with hardware, you're probably going to need to know C, okay? Because it has a very close relationship with the underlying hardware. Again, C is very high performance, so anytime you're in a situation where performance is critical, C is going to be one of the languages that you're probably looking at. Game engines use C extensively, real-time systems, so devices you might not even know about. If you go to the hospital and they put you on a respirator, that respirator might be running software that was originally coded in C. Certainly high-frequency trading algorithms, so if you get into, you know, financial development, those systems, those bots have to be able to execute trades at sub-second frequencies. So you're going to want as the maximum performance possible. C is heavily used in that industry as well. Certainly in embedded systems, you may have heard of the term the Internet of Things, or IoT. That sort of refers to the fact that it used to be that we only had laptops and PCs on the internet, and now we've got washing machines and fridges and freaking toasters. They're all connected to the internet these days, and that's been termed IoT, the Internet of Things. And the rise of IoT has led to a surge in embedded systems development. So now, you know, rather than developing apps for a laptop or for a mobile phone, you're developing apps for a very resource-constrained device that doesn't have a lot of CPU power, it doesn't have a lot of RAM. So you need to develop very, very efficiently, and C is often the language of choice for that sort of thing because it's very efficient and it gives you strong control over your resources. If you want to get into any kind of contributing to open source projects, there are a huge number of really big projects out there that are developed in C. Obviously, Linux is the prime example there, but there are tons of others. Database systems like MySQL, PostgreSQL, and so on. Contributing to open source can be a great way to gain some experience with software development and put something on your resume that's attractive to employers. So knowing C allows that possibility. It opens that door for you. Now, I hesitate to make this point about legacy code because I don't want you to think, well, C is just for old programs. Nobody uses it anymore to develop new programs. That couldn't be further from the truth. But the fact remains that there are literally billions and billions of lines of C code out there in all of these existing applications that have been developed over 40 years. Companies can't just decide, okay, well, all the cool kids nowadays like Python, so we're just going to throw away our insurance applications and all the programs, you know, powering our tax system. No, those are all running like C code and, well, even older than that, COBOL. But the point is that there's a lot of existing C code out there. And so the ability for you to go into a company and be able to, okay, yeah, I know C, I can pick that software up, I can maintain it, make changes to it. That's going to be a valuable skill for you and potentially very lucrative. You guys might have heard of, back in the year 2000, the Y2K problem. So, you know, since the 1960s, all of these companies were developing software and they were all using 2-digit years for their dates. So what happens at the end of the millennium? We get to 1999, so that's 99 because they're only using 2 digits. And then when it goes over to the year 2000, all of a sudden it changes to 00. So the following year is less than the previous year. 0 is less than 99. And so there was a big panic in the 90s to that, you know, we have to update all of our systems, the world's going to implode, nuclear bombs are going to go off, that sort of thing. And so a lot of companies were investing a lot of money in updating their software so that they would use 4-digit years for their dates. Now, at that time, there was a lot of this software running on these big mainframes in insurance companies and government and big corporations. They were all running COBOL. COBOL is this really old arcane language. And I can tell you that at the time, the old guys who had retired were being called in left and right to do consulting because they knew COBOL and none of the new programmers did. And so they were able to come in and just make a fortune updating all kinds of software for these companies to avoid this Y2K bug. So I'm not saying that's necessarily going to happen with C, but who knows? 20 years down the road, we could be in a situation like that. And so having the ability to program in C could potentially be lucrative for you. Finally, extending languages. A lot of the languages that you know and use are written in C. Python, written in C. JavaScript, written in C. So knowing C allows you some insights into how the languages you use work under the hood. It also allows you to extend them. So if I'm writing, say, a graph algorithm in Python, and let's say that it's operating on my graphs, and my graphs are really, really big, and it's just taking forever for my program to finish, to terminate on this input graph. What I can do is I can write that algorithm as a C module that I can then call from my Python code. Now, in my Python program, it'll look like I'm just using another Python library. But really, behind the scenes, it's written in C, so it's a lot faster and a lot more performant. And I've actually done that in the past. It's very useful. So yeah, knowing C allows you that ability as well. So that's my case for why you should care about Linux and C and come to class. So not to belabor the points, but this is a snapshot of what's called the TIOBE index. The TIOBE index has been around since 2001. They sort of measure the popularity of programming languages based on a bunch of different factors. Google search results, YouTube hits, blog posts, that sort of thing. Since 2001, since the inception of this index, C has never gone below rank number 2 in terms of the most popular languages in the world. I think most recently it was like 2021 or something that it was at the number 1 spot. Okay, so you can see like languages have sort of, you know, gained in popularity and then waned. Certainly Java was hugely popular in the late 90s and the early 2000s. It's still very popular, of course, but it's not the hot language of the day. Python in recent years has really supplanted it as the popular language, but throughout it all, C has just remained constant as, you know, one of the most popular and most used languages in the world. Okay, so let's talk about the resources you have available to you to be successful in this course. We will be using OWL for this course, so make sure that you're checking that regularly. I will be posting all of our materials there, our lecture notes, labs. I am going to try and record these lectures. I am recording my voice right now. I'm going to see if it works. I don't guarantee that it's going to work, and I don't guarantee that I'll have time every week to edit the video and post it online, but I am going to make a best effort attempt to post these lectures. So that way, you know, if you're sick, just stay home. We'd all prefer for you not to bring your germs in here. So my hope is to be able to post them online so that if you're sick, you can still catch up on lectures. We're going to talk in a little bit. We're not really going to be using email in this course, but you know, if there's an emergency, if it's 2 hours before class and I wake up and I'm sick, I may push out an email to all of you folks. So make sure that you are checking your Western email. If you use an external service like Gmail, just make sure that you're forwarding your mail. Okay, textbooks. C Programming, A Modern Approach. This is an older book. It's from 2008. It is a good book. So I read the first edition of this book when I was a CS 2211 student back in the day. It is actually a really good readable book. I read it, I think, cover to cover because I'm a loser, and it was pretty good. So I do recommend it. Having said that, I'll leave it to you. I think this book's kind of expensive. I haven't looked at the bookstore, but certainly I was looking at Amazon and it was outrageously expensive. So I'll leave it to you whether you think you need the extra help. We will be covering a lot in lectures. Obviously, in any university course, lectures do not teach you everything you need to know. You are kind of expected to do some supplemental reading, but I'll leave it to you to decide whether or not you feel you need extra support. Same goes for your Unix and Linux. I haven't read this book. I did flip through it. It looks reasonable, but really any introductory Linux book would suffice. And again, that's really only if you feel like you need that kind of extra support. So, evaluation. There will be 12 labs in this course. That's worth 10% of your mark. So we are going to drop your lowest 2 labs. So you make sure that you come to 10 out of the 12 labs, and then you get the full 10%. 5 assignments worth 30%. We will have a midterm in our regular class time on March 7th. I know it's lame to call it a midterm when it's a month before the final exam. It just kind of worked out that way. Just think of it as a way to consolidate all of your knowledge a month before the exam so that you're better prepared for the final. So the midterm will be 25%. Final exam will be 35%, and that is, of course, scheduled by the registrar, so make sure that you are not making travel plans until the date has been set. Standard rules apply to obtain a passing mark in the course. The weighted average of your midterm and final have to be 45%, and the weighted average of your assignments has to be 45%. So in other words, you can't, ace all of the assignments and fail the exams, or vice versa. Okay, so the labs. The purpose of the labs is to sort of give you a relaxed environment where you can just sort of go in a fairly stress-free environment and get some hands-on practice with the course concepts. The TA will be there. You can feel free to interact with them and ask them questions. You can also feel free to collaborate with your peers. So if you guys want to work through the labs together, that's totally fine. What I would say is that all of you should be typing things yourselves. So don't do like a pair programming situation where you sit and only one person types. Work individually, but feel free to talk amongst yourselves and work through problems together. There's nothing to hand in for the labs. It's basically you show up. At the end of each lab, there will be a little section in the lab instructions that says what you should show your TA. So you show your TA that whatever you've done, and they will mark your lab as complete. Okay? As I say, you only need to complete 10 out of 12 labs. So if you're sick and you miss 2 labs, you still get the full 10%. But we do recommend that you attend all of the labs because it's just extra practice for you. I should mention that labs are starting this week. So for those of you who are enrolled in the Tuesday lab, that's this afternoon in MC 244. Now, if you miss labs, for the first 2 labs, we're already giving you academic accommodation because we're dropping them. So we will not, don't email me and say, oh, can I get, an extension or can I redo this lab because I missed it? No, we've already dropped it for you. After the first 2 labs, if you miss more labs, follow the procedure in the course outline for academic accommodation. And I should point out here, where did my owl go? No, there we go. So I should just point out the course outline is under general information, and you'll see the course outline there. So have a look at that. You might want to have a look at the assignment submission instructions, and of course we've got lecture notes, labs, and so on. So if you miss more than 2 labs, follow the procedure in the course outline for academic accommodation. If you are approved by an academic counselor, they will email us, and you should then complete the lab on your own. And then in the next lab after your accommodated days, you would then show your TA your completed lab. Okay, assignments. The format will be concept questions, so some general, there's not a lot of theory in this course, but just some non-programming questions. Questions about Linux commands, C programming problems, and later in the course some shell programming as well. Assignments, of course, are an individual effort, so please don't let other people look at your assignments. Don't look at other people's assignments. Don't go and ask ChatGPT or GitHub Copilot just to write your whole assignment for you. On that note, my policy on ChatGPT is we cannot ignore it's here, and it's an awesome tool. I literally use it every day. How many people have used ChatGPT? Okay, so most of you, that's good. It's a wonderful tool. It's absolutely fantastic. It makes me more efficient on a daily basis in everything I do. Sometimes I just go and talk through a problem with it. I'll explain a problem that I'm having in my code. I'll say, look, you know, do you have some suggestions? And we'll just kind of talk through it, and it'll give me stupid suggestions, and then I'll berate it, and it'll give me more stupid suggestions. But sometimes it gives me really good suggestions that save me a lot of time. So absolutely feel free, you know, if you're stuck on an assignment and maybe the compiler is giving you some weird error that you don't understand, paste it in there and say, look, what's going on? Give it a little snippet of your code. I'm totally fine with that. What I'm not fine with is going to ChatGPT and saying, here's my assignment description, write my code for me. Obviously, that's an academic offense. Now, in all honesty, what your other profs probably won't tell you is that they will never know if you do that, most likely. But you'll know, and you're just kind of screwing yourself over, because why are you paying all this money to be here if you don't want to do the work, right? So that's my spiel on ChatGPT. Use it as a resource for sure. If you run into problems or you need clarification that maybe you're afraid to come and ask us, you know, I didn't understand that topic in the lecture, go ask ChatGPT. It's awesome for that kind of thing. Just be aware that it frequently lies. It will just make things up all the time, okay? So you have to sort of be a little bit suspicious about what it tells you, because sometimes it just outright lies about things. So, yeah, that's my spiel about assignments being an individual effort. Make sure you're checking the course website regularly for updates. I may be posting updates or corrections. I might put an FAQ on the assignment page if, you know, a lot of people are asking a specific question. So make sure you're checking that, monitor the website, take a look at the forums and the announcements. We will be marking everything in on the computer science undergraduate server. It's compute.gall.csd.uwo.ca. We'll be seeing in the next lecture how to connect to that, and in your first lab this week, you will be connecting to that as well. So what you need to do is make sure that you leave enough time after you're done your assignment to take your code and test it out on that server. We will not be marking your code on a lab system. We won't be marking it on your personal laptop. We're only going to mark it on that server, so you got to make sure it runs on that server, okay? Now, I am going to show you in the next lecture how to set up your individual laptops so that you can have a full-blown Linux or Linux-like environment on your system running the same C compiler that we're going to run in this course. So you shouldn't really have any issues if you develop the code on your own system and then move it to Gall, or move it to the compute server. But just make sure that, you know, you leave a few minutes at the end of the assignment to make sure that it works. So assignments, there will be 5 assignments. The first assignment will be due next Friday. I will be posting that this evening. It's not going to be much. It's a 1% assignment. It's just sort of to get your feet wet, to make sure you've all logged into our compute server, try out some basic Linux commands, that sort of thing. So it's not going to be a heavy assignment by any means. And then we've got a few 7% assignments, and the last assignment will be a little bit heavier, 8%. So all of your assignments will be submitted via a tool called Git. Git is a very widely used version control system. It is essentially required knowledge for software developers these days. All the big companies are using Git to manage all their source code. You can think about it this way. Let's say you work for Microsoft and you're developing code for Windows. The developers aren't all sitting there on their laptops developing their code and then just keeping it there day after day. And then eventually, when it's time to release the next version of Windows, they just sort of email it all to, you know, one guy who puts it all together and builds it. They're checking in their code every single day and multiple times a day to a system like Git, if not Git itself. Okay, so it's called a version control system. We are going to be getting some experience with Git by using it to submit our CS2211 assignments. So there are submission instructions on the course website. You should have a look at those. When you look at them, you're going to say, holy cow, it's a 6-page document just to submit my code. Don't panic. It's a bit of a complicated system for people who are new to Git. So I made sure that I explain things in detail. but really it's only a few commands when it boils down to it to submit your code, and you will be getting practice with it in labs 1 and 2. So yeah, you should be just fine when it comes time to submit your assignments. Assignments will be due in your Git repository by 11:55 p.m. on the due dates. So far, I have scheduled all of the assignments to be due on a Friday, so it would be, and unless otherwise notified, it would be 11:55 p.m. on the Friday that it's due. And then if you have requested academic accommodation for an assignment, there is a form that you have to fill out and include with your assignment submission. All of those instructions are in the assignment submission instructions, so make sure you check those out. Late policy, after 11:55 p.m. up to 11:55 p.m. on the Saturday, it would be 10%. Up to 11:55 p.m. on the Sunday, it would be 25%. And then after Sunday at 11:55 p.m., we don't accept it anymore, unless you have accommodation. So getting academic accommodation for assignments, again, take a look at the course outline, follow the standard accommodation procedure. If the counselor recommends 5 days or fewer, we will automatically grant you the extension. You got to fill out the form. It requires you to paste in the email that they sent to you. There's no need to contact us. You just submit your assignment along with that form, and it will be marked and you'll receive your accommodation. If they recommend more than 5 days, make an appointment to meet with me in my office hours. We'll discuss an appropriate deadline. And then once you have submitted your assignment, you message your TA through OWL and they will mark your assignment. So the key thing here is, again, you got to remember your form. So it's just a simple text file. You just fill it out with the assignment number and your name and some basic details, the dates that you received accommodation for, and you paste in the email from your counselor. Okay, it's pretty basic stuff. You include that along with your assignment. Academic accommodation for exams. Again, follow the standard procedures. If you miss the midterm, I'm not doing a makeup midterm. We'll just shift the weight of your midterm to the final exam. If you also miss the final, then you can write the makeup final. If you miss the makeup final, then you got to retake the course. Yeah, scholastic offenses and ethical conduct, just, you know, I mean, I hope you guys know this by now. Don't cheat, you know, don't try to hack people's accounts. Don't log into somebody's lab account and delete their files, that sort of thing. So make sure you're responsible with the policies on scholastic offenses and the rules of ethical conduct. Okay, course communication. So we are not going to use email in this course. If you email me, I may not respond. It's not that I think that I'm so important that I just can't, you know, talk with lowly students. It's nothing like that. It's that presumably, you wouldn't know it by looking at you, but presumably there are 170 students enrolled in this course. So we have to have some means of keeping things sane and organizing our communication. So we're going to use OWL forums and messaging. Okay, so if you go into OWL, I'm using the wrong mouse. So if you go into OWL, you will see the forums in here. Whoops. Okay, so I've got a bunch of forums set up, general discussion, labs, assignment 1, and as more assignments come out, these will reveal themselves and you can post into those as well. I have made the forums anonymous. Some people are sometimes afraid to ask a question because they think that, you know, maybe they're going to look dumb, even though probably half the class has the same question. So to get around that, I've made them all anonymous. What that does is it makes sure that nobody can see who it is that's posting. We still can as instructional staff, but your fellow students cannot. So feel free to ask questions. If you know an answer, feel free to answer up here. That would be great. But yeah, have a look at the forums, and if you have a question that is relevant to the class, then post it in the forum. That way everyone can benefit from it rather than email or messaging us directly. One thing, if you're posting in the forums, you shouldn't include any code or any assignment answers. It's common sense stuff. But if you have, you know, questions about, I don't know, clarifying an assignment, questions about the midterm content and so on, feel free to post it in the forums. If you have individual concerns, or if you have any questions where you need to send us some code and have us look at it, then send it via OWL message. In the notes that I posted online, it did say that you need to send to the teaching assistant role. I actually had to make them secondary instructors. So if you wanted to message all TAs, you go to Messages, Compose, and you go Secondary Instructor. That will message all 3 TAs. For the most part, you're probably just going to message your individual TA who teaches your particular section. And of course, if you want to email me, you can go to the instructor role. I think I've got, yeah, there's 2 of me in here because one of them is my student account that I'm using for testing. So just to be sure that it goes to the right one, just go to instructor role and that will email me, okay? So if you have questions about your assignment marks, you should direct them to your TA, the TA who marked them. If you're still unsatisfied after contacting them, let them know and they will then discuss the situation with me and then we'll figure out what to do from there. Again, if you want to contact me, send to the instructor role. So examples of things that you would use the OWL messaging for would be assignment questions where you have to email code, and again, questions about your marks and so on. I will say that, you know, we want to be helpful. We're probably not going to entertain questions where, you know, here's my C code, it's not working, debug it for me. You know, you need to tell us what you've done, tell us what problem you're running into, and then we're sort of more inclined to, okay, yeah, so your next step then is maybe to try this, okay? Lastly, in terms of getting help, I will be holding a weekly office hour via Zoom on Tuesdays from 2:30 to 3:30. So this will require sign up. These are private sessions that on OWL you can sign up for them. There will be 5 12-minute sessions each week, 10 minutes for consulting, 2 minutes for changeover. This is new to me. I've never done consulting on Zoom before. I know that in this course, apparently they do it all the time and it works well. So I figured we'd try it out. It's more convenient for you. I remember it was always a pain to have to get on a bus and come into the school to get help. So now you can just sort of zoom in from wherever you happen to be. So the sign up form will be available weekly on the course website. You can sign up for a spot if you need to talk to me. They will be private sessions, so you can share your screen. We can look at your code. Again, I will do my best to offer you suggestions and pointers for what you should try next. I'm not going to sit there for half an hour and step through your code line by line with you. And again, it's not because, oh, you know, I'm too important for that. I am a firm believer, and it has been my experience in my professional career that learning to struggle through a problem makes you better. It makes you a better developer. You have to build up that self-confidence and that self-reliance where now I can, any programming problem that I face, you know, it might be a really tricky problem and I'll think to myself, oh, this is going to take days. But I always have that confidence in the back of my mind that, yeah, no problem, I'll be able to figure this out. It's just going to take a bit of time. So really having the experience of struggling through problems and not just, you know, giving into the instinct to immediately ask a question as soon as you run into the first sign of adversity, that makes you a better developer. So anyway, that's the end of my rant on that. I will help you. I'm just saying we're not going to sit there for a half an hour and step through code. The TAs will also hold a weekly office hour. So if you take a look at the weekly schedule, okay, you can see all of the labs and who's teaching them. You can see all of our office hours. We will be posting our Zoom links. The office hours will start next week, okay? It won't be this week. So I will have Zoom links posted. The TA office hours do not require sign up, so you can feel free to join them. They will not necessarily be private sessions, however. So there might be 2 other people in a given session when you go in. If there's a situation where somebody needs to get some help with their individual code, the TA may take you into a Zoom breakout room so that you can talk privately. So if you join one of these sessions and the TA is currently in a breakout room, don't worry, just wait and they will be back soon. And then as I said, another means of getting help is to post questions on OWL. Just make sure you're not posting code. Feel free to message us through OWL. And you can, of course, ask us questions in the labs and before and after class. So that's all I've got for you today. Do you folks have any questions? Yep.
So I see the owl and the lab, the lab one, and the due date is January 15th?
So the due date of the lab, no, that's just saying the week of, it's just saying that this is the lab for this week. Your lab is due at the end of your lab session each week. Okay, so you're expected to go to your lab, do the lab, and then your TA gives you the mark at the end of the lab for showing up and doing it.
So the first lab will start at the next week, right?
The first lab will, sorry?
Start at the next week.
No, the first lab starts this week. So if you're enrolled in the Tuesday labs, it's this afternoon.
Oh, okay.
Yep,
Thank you very much.
no problem. Any other questions? Okay, folks, have a great day, and we will see you on Thursday.